recording, and I think I need to share screen. Chuk, 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 chuk. What is the R Studio? Yeah, I think that's okay. So I will start a new script. So we have R for finance class 2. What we'll do today? Today we will do some more advanced data transformation, because in my opinion, uh, almost every time you spend more time not on model evaluation, but on data processing. So because all the complex models, not all, but many complex models are already built in, are already, it's very, it's very rare case when you need to create, to introduce likelihood function by hand. So many models are already coded. So basically you just need to find a package that suits your need, and that's all, and to prepare data. Okay, so so we start today with more advanced, more data wrangling. And after a break, I think I will discuss a little bit ETS models for time series, because basically we are interested not in R in general, but in time series, working with time series in R. Okay, so that's our plan for today. And so let's start with some data manipulations techniques. So I will attach some packages, tidyverse, that's for data manipulations, plots. Okay, I will also attach some standard packages like Rio for input, output. Even if I will work with built-in data sets to speed up the process a little bit, you should know that you have import export, and you can read and write almost all imaginable data formats. What else will I need? I don't know yet, but basically I think that okay, so I will take Diamond's data set. I will abbreviate it D for short. Okay, so let's look at our data set once again. And the operation I would like to speak about next is grouping. So next operation is grouping data by a factor variable. Oh, I will more. Okay, what do I mean by grouping? So imagine I just, there are functions that takes a vector and transform a vector into a number. So there are functions, there are many functions that take a vector of numbers, and they give you a number, a scalar. Who can give me example of such a function that takes a vector and gives me a scalar?
Summation operator?
Yeah, for example, a sum. Yeah, if I have a vector v that is, I don't know, I don't care, 5, 6, minus 2. Yeah, I can say sum v. Sum v. It takes a vector and gives me a number. What are other possible functions?
functions like that.
We can find the length of the vector.
Yeah. But about statistics, I think that mean of v, or something like standard deviation of the vector v, and so on. There are many functions. Maximal value. There are many functions. Yeah, length of a vector in a geometric sense. Yes. Yeah, there are functions that take a vector and give me a vector. Like, so there are functions that like vector, and they transform it to a vector. Like, for example, cosine. If you apply it element by element, cosine of v will not be such a function. Cosine of v, it takes vector and gives you a vector. And many functions. Okay, so I will use the functions of the first form. So they will take a vector of numbers and they give me a scalar. And using these functions, I can, for example, summarize my data set. So example, I may summarize. So like I take D and I say summarize, and I say, let's say, mean price is equal to mean price, and I don't know, std of price is equal to standard deviation of price, and I don't know, maximal carat, maximum weight of a diamond is maximum of carat, uh, and this is a short summary. Yeah, short summary. Okay. And so this is short summary, and I have, instead of 3 columns, I have 3 numbers. Yeah, mean price, 1 number, 1 scalar instead of a vector price. Standard price, a scalar instead of a vector price, and max carat, 1 scalar, maximum weight of a diamond instead of a vector. Okay. Everything is clear up to now?
Yes, everything's clear.
Okay, let's move on. And now we can introduce grouping data by factor variable. So there is a special command. It does nothing by itself. So there is a special command, like it's called group by. This command calculates nothing. Calculates nothing. So if I, for example, say group by, or maybe before working with group by, I have used natural order of operations. So I say take data frame and then pipe. This is pipe operator. We have discussed it 1 week ago. And basically, if you like to do the same thing with, so basically from language point of view, this pipe operator just substitutes d as the first argument of the function, of the next function. So basically, I can write using all the, because here I have only 1 operation, so I can write using old style. I can do like this. So that's the same thing. Pipe just moves what is to the left of pipe as a first argument of the function to the right of the pipe operator. So basically, this is the same thing. Okay, so this is like pipe style syntax, and this is like Euler style syntax. The result is the same. Okay, now group by comes in. Okay, I will do basically the same, but I will first do group by. I say group by some factor variable.
by, let's say, variable cut. And then I will do my summarize. I will just copy it and I will do my summarize. Okay, and let's look at our short summary once again. So now we have what we have done basically. What's going on here? We have a big data frame. Yeah, let's write the head of this. Let's look at the head of our data frame. Head D, let's say 5, or let's say 7 first elements. So I have a big data frame. If I just do D pipe summarize, then I have just one number instead of a whole column. A whole column, big column of 53,000 numbers is transformed into one number. So I have 3 numbers: mean price, standard deviation of price, sample standard deviation of price, and sample maximum of weight of a diamond. If I insert group by comment between my data table and summarize operation, these vector to scalar functions, they work not on the whole data frame, but they work on each chunk, on each piece of a data table separately. Okay, so I have 5 chunks of my big data frame because I have 5 types of cuts in my data set. So there is a fair cut diamonds, premium cut diamonds, very good cut diamonds, and so on. So basically what is done here, my big data set is divided into 5 subgroups, and these vector to scalar functions now work on each subgroup, on each chunk of my big table separately. Okay. Any questions?
Okay. Okay, it's clear.
So I may group by many. So I may cut into small subgroups by many factor variables. I cannot use here continuous variable. That will be a bad idea because every row will be a group. It will be meaningless. But I can use factor variable, character text variables. I may use 2 variables here. So for example, I may do something like this. I think color is also a factor variable. It has it's not numeric. It's I have just some colors, so I may add here color, and there will be much more groups. So I will have a separate group: fair cut diamonds of D color, mean price for them, standard price for them, max carat, and so on. So I will have a fair cut with E color and so on. So I will have every combination. Okay, so group by itself does nothing. If I just, for example, will print, so group by only changes the behavior of this mean, of this standard deviation, and of that maximum functions. So you will almost not notice the difference. So if I type D, you will see that it is a table with 53,000 rows and 10 columns.
if I just write d group by cut color, you will see almost no difference. There is a small notice that now the data set is grouped by two factor variables, cut and color. And basically that means that the data is the same. No values are changed. You have exactly the same number of observations. You have exactly the same number of rows. But when you will calculate minimum, maximum, length of a vector, I don't know, average, median, sum, product, all operations that transform a vector into a number, into a scalar, they will change their behavior. On the ungrouped data set, they operate on the whole column. On the grouped data set, these vector to scalar operations, they operate separately on each sub data set. Okay, and that's very useful. So, for example, I can easily calculate deviations from mean in each group. So what I can do, I can not only do summarize, I can do, for example, mutate. We have already used mutate to introduce new variables. So for example, I can combine, usually we combine, we put group by before summarize or before mutate. So for example, let's calculate deviations from group means. So I will something like say d2 equals to d group by cut, and then I say something like mutate def price equals to price minus mean price, and maybe it's better to add something like mean price equals to mean price. And let's look at our D2 data frame. Had D2 10 observations. So what is going on here? My data set is grouped by which factor variable?
By caret.
Yeah, by cut. By cut. It's grouped by cut. So this observation is in one group. The second observation, the fourth observations, and so on are in the premium group. Observations number 6, 7, 8, and 10, and so on. There are many more. There are 53,000 observations. So they are in a third group of observations. And what I have done, I have calculated mean price. Because I have group by here, the behavior of mean is changed. So mean works separately for very good diamonds. So here the mean is different from premium mean. And I can calculate deviation of price. So this deviation calculates the difference between price and average price of the corresponding group, not of the whole data set. Okay? The grouping operation is clear?
Yes, clear. And could you please explain the first column, which is DBL under caret. What is it? It is
Which one?
the very first.
That's the type of the variable. So you have, so that's if you just look at D2, it's not the first column, it's a type. So you have a double, it's abbreviation for, you have a real float point numbers like 0.23, and double means that double precision number is used to store this number in memory of computer. So basically that means for us that means numeric, basically that. So if you work with really big data sets, maybe in that case you should care whether your variable is integer. It can take only values 1, 2, 3, 4, 5, 6, 7, and so on, only integer values. And in our case, it says double, so that means it's a float number. It's something like 75.32. So basically, it's numeric. But if you work with big data sets, maybe you should care, oh, they double precision numbers, so it may take a lot of memory. If my data set is too big, maybe I should move on to integer numbers to store or something else. Okay, what does it mean cut? Cut is ordinal, so it's not only a factor variable, it has a special structure used in some statistical methods. I think we will not encounter this structure in time series, mainly in econometrics. You have something. Ideal is they are ordered factors. So ideal is better than good. Good is better than fair. Very good is better than good, but less. So and so on. So you may, let's say, something like D2, like cut. I think something like class maybe. It's ordered factor variable, and if I'd like to see the orders, so this it knows not only the cut of each variable, but the ordering fair is less than good, is less than very good, is less than premium, is less than ideal.
And for example, in other data packages, like in state, we have dummy variable, and dummy in its term do not have such quality. I mean, by ordering the groups. Yes?
Yeah, dummy are usually encoded like 1, 0, so they may be integer. But normally we don't introduce, we can introduce dummy, but normally when you put something into regression, R will introduce dummy for yourself, for you. So you basically, in most cases, we don't care. So for example, if I will include, so if I will include some dummy in regression, so I may just write something like model equals to LM. So I will I will use non-robust standard errors to show you the idea data is equal to diamonds. What do I say? I say price on caret plus cut. And I think that's all we need. And we can see summary model. Yeah, it's even trickier. So let's just a moment. Because of the, so you don't know this algorithm for stability, there are some I think it's Chebyshev polynomials are used, so for improved stability of results. R uses more subtle techniques here than Stata with dummy variables. But so how may I avoid this advanced behavior? Just a moment. I will show you the way how R automatically introduces dummy variables and how we may introduce them by hand. Just a moment. Just a moment. Because it's a little bit complex, more complex than we need. So I need to just a moment. I will just 2 minutes. I will answer your questions. So how to LM ordered factors, ignore order. Regular factors. Okay, let me do like this. Maybe I can do like factor cut. No, it's just a moment. Unordered. No. Just a moment. I will think a little bit. Because I don't like to go into details with Chebyshev polynomials. That will that's just a moment. I will find okay, let's I will just, maybe it's a better, maybe there are some options for LM comment. I will just ignore the ordered structure. So I will just add I will do like that. Okay, let's introduce dummy variables. I will create D3 like D mutate, and I will introduce cat2 like as factor. Cut, and I will say is ordered equal to false. I will remove order. Maybe I think there is an option in LM comment, but I don't recall it. So I will do it my way. Maybe it's not optimal. So I will just remove the ordering from cat variable. So if I look at WIMS D3, I will have cat2. It says factor variable. So that one is ordered, and that one is factor variable. And if I just add here cat2, then I will have, oops, sorry,
D3. Yeah. And now I have dummy variables introduced automatically. Maybe there is some option inside the LM functions. I don't remember. But the idea now is clear. So what we have, because we have a lot of values of cut variable, if we order them by alphabetical order, the first one is fair, the next one is good, very good, and so on. So we have R has introduced automatically dummies. So this is indicator that the cut is good. This is indicator that the cut is very good. That is indicator that the cut is premium. And that is indicator that the cut is ideal. Okay, so dummy variables are introduced automatically. That's the first idea. So what I have done, I have removed order information from cut variable. I can choose base category. So for example, if I say factor so how do I choose base category? I think it's like maybe I will do S factor. Just a moment. I will explain you how to change S factor. Order it false. I can just add any. Okay, so let me reorder them. Okay, so first, so let's do it step by step. The automatic introduction of dummy variables is clear. Yeah, I think let's do it step by step. Ooh, automatic introduction of dummy variables, is it clear?
You mean by mutate?
No, I mean, if I have a factor variable that is not ordered, LM comments introduces the dummy variables automatically. Is that way clear? So that here I have only removed information about ordering of fair, very good, and so on. So I have removed information from order of factors.
Yes, that's clear.
Okay, so if I would like to introduce dummy variables by hand, so first case, LM comment will introduce dummy variables automatically. But if I'd like to introduce them manually, I can do that. I can say we may introduce dummy variables manually. So how can we do this? Let's say D4 equals to D3 mutate. Oh, we may say even diamonds mutate, and we may introduce like that good dummy good equals to case when
And we say something like the syntax is a little bit special, but it's very powerful command. We may introduce a lot of conditions in one command, and we may change almost, we may introduce very complex conditions with this case when command. So in our case, when cut is good with big, starting with capital OK letter, good. Then we say that our dummy variable is 1. And because conditions are evaluated one by one, we may say that otherwise, if cut is not good, we may say that this is 0. Okay, I have introduced D4. D4. Let's look at our dataset D4. So I have introduced manually dummy variable that is 1 if my cut is good, and this is numeric variable, and I may insert this numeric variable into regression. Good. And so I have inserted a dummy variable, this good. It takes value 0 or 1. Okay.
Yes, yes. And case when means if we go through it step by step, good if 1 if true and 0 otherwise. Yes.
Good. No. That means you may introduce a lot of complex conditions, like, for example, I would like to group by ideal and premium groups into one. So what I will do with case when. Case when is just check if the cut is good. If cut is good, then assign 1 to my new variable and go on to the next condition. The next condition says if true, and true is always true. If true, then assign 0 to my variable. For example, if I'd like to unify ideal and premium into one new factor, into one new level, so what can I do? I can, for example, like d5 equals to diamonds. Diamonds mutate, I don't know, cut united, like case when cut is in ideal or premium, then I will say that, so I will, oops, and I will say that is ide prem, and if true, I will just save old cut. So it checks if cut is in the set, then the new value of my cut united is idprem. And if the first condition is not satisfied, then cut united is just equal to cut. So this function case when checks conditions one condition by one. What is the problem? Let's say as character. What's wrong? Something is wrong. I have a missing bracket. What's wrong? Like this. Yeah, like this, it works. So add D5. We have united two factors into one. Okay.
Yes, I see. Great.
Is when one more example. How to change base I think how to change base the base level. So by default, the base level of a factor in regression is the first in alphabetical order. So when automatically dummies are introduced, here in this example, so because the first one is fair, so fair is a base category. And I think that we make something like relabel a library for cats, or for cats if you like cats. So it's anagram for factors for cats. So if you like cats, so you can easily change the base category of a vector variable. So it means for cats, I think it's something like relevel. Yeah, relevel. Reorder, so the level specifier f is first and the others are moved down. Okay, yeah, we made something like relevel. So I will do like this. Oops. So I will say that. I will say also that I'd like to relevel, and I think that I will choose as a base category. I will choose, for example, good diamonds. And now if I do the same regression, there will be so now I have a fair dummy introduced and good dummy that is not introduced, because I have chosen the different base level for my factor variable. Okay.
Yes.
Okay, I think we have finished with dummy variables. Now let's go on. So the next operation that is useful is so we have grouping, so we can change, we can group table into smaller subtables, and another one operation, we can pivot the table in the long form or pivot the table in the wide form. So we have pivot operations. So let me, yeah.
Could you once again repeat what did you do in the last step with the relevel?
With relevel, just let's see the difference. D3 bis, D3 bis, model bis. Okay, so in econometrics, you know that if you include constant, and the constant is included, then and if your factor variable has a fair, good, very good, premium, ideal 5 levels, how many dummy variables should you introduce? If you have a constant in the model and your variable has 5 levels, how many dummy variables are you introducing? That's a simple econometrics question.
By one level less?
Yeah, by one level less. So, and by which one? So, and it's a matter of choice. You may, yeah, you are right. You introduce 4 dummy variables, constant,
if a factor variable has 5 levels, then you use constant, that is called intercept, and you have 4 dummy variables that are introduced automatically. But you need to choose one level, 1 out of 5 levels as a base level. Okay, so these 4 variables will be 0, 0, 0, 0 for base level. Okay, and by default, if I don't care, if I just don't care, by default, the base level is the level that is first in alphabetical order. So if there are 5 levels, fair, good, very good, then as F fair is the first letter in the alphabet, before good, before premium, before P, and so on. So by default, you will not see dummy variable introduced for fair cut diamonds. You will see dummy variables, 4 dummy variables introduced for good diamonds, for very good diamonds, for premium diamonds, for ideal diamonds. And if I have changed the base level, so I've said, so the base level is good. And now if you see at model BIS, then you have a dummy variable for fair diamonds, but you have no dummy variable for good diamonds. Okay.
I got it. Thank you.
Okay. I think that maybe it's better to move it. So I think we don't even need for cats. I think it's better to move it here. Yeah, like that. Now, what do I mean by pivot operations? So sorry, I missed a question from Johnny Beck that could you please tell again, our price deviations are from mean price of group or mean of all prices. That depends whether the operation is preceded by group by or not preceded by group by. If it's preceded by group by, then all vector to number operations are done group wise. If it's not preceded, then we just work with common mean, with common standard deviation, and so on. So if you precede your operations by group by, so the question was by Johnny Beck. Yeah, so it depends. So this is the difference. If you have this group by, it affects all future vector to number, vector to scalar functions. If it's not preceded, the vector to scalar functions, they just work on the full data set. Okay, what do I mean by pivot operations? Let's take this. I will just, yeah, let me take my short summary. And let me show what is a pivot operation. So for example, I have a data set like this, and so sometimes data set are preceded by a computer. And so in this case, it's important that the number of columns is constant, and that every new operation, every new observation is added below my data table. But in some cases, when you present your data in a table form,
sometimes it's better to like have a different structure of the table to represent the same data, but using a table of different structure. For example, I would like to move these numbers, mean price. I like to have them in a table, but I like to have a cut on, let's say, in a column. I'd like to have color in a row, and mean price, I'd like to have it inside a table. So, for example, imagine that I would like to have a cut as a column name, color as a row, and mean price in table. Yeah, as a, okay. So I would like to remove standard deviation of price and maximal caret from my table. I would just like to reorganize these three columns, but to move one variable will be column titles. Next variable will be row titles, and third variable will be inside the table. Okay, so it's just the same table, but presented differently. Okay. So that operation is called pivot longer. Pivot longer. What do we have here? We take data from our short summary. We take calls will be like cut. Yeah, that will be cut. There will be what else do we have? Values. Just a moment. I will see an example. Pivot longer. Oh, sorry, pivot wider. Ah, yeah, we need pivot wider. Sorry. Our new table will be wider than before, so we need pivot wider. Yeah, pivot wider. So we need our data, ID calls, yeah, ID rows, and so on. Okay, we do pivot wider. We say our data from short summary. We say names from cut. We say values from mean price, and then we have let's look at this. No, that doesn't work. Maybe we should yeah, we should select from our summary. We should select color. Sorry, we should select color, cut, and mean price. Mean price, and I think that will work. Yeah, like that. We have color, we have 5 cuts, and we have mean price in our new table. So let's do it maybe step by step. Step 1, we remove unused standard price, standard deviation of price, and maximum of caret. So let's do it one step. Let's
short sum selection. And here we have short summary selection. Yeah, I think that's a little bit better. Okay, have we succeeded? Any questions about pivot wider? So we can take one column and use it as a column names. We can take other variable and fill in the table, and the remaining variable will be used as a row names. Okay.
So values are our rows, yes?
Color, DEF.
I've asked the values there is our rows, yes, am I right?
Sorry, values.
Values from, is it rows for pivot table for the
No. Let's look at original tables. So short summary selection. So that's our original table. We have 3 columns. We have removed 2 columns we will not use. So we have color column, cut column, and mean price. There are more rows. They are just not shown. Yeah, there are more rows. Be careful, that's not a full table. Okay, so we have 3 columns, and we use cut column as a so these values will be in so cut will be used as column. Mean price will be used as values for the table, and color will be used as a row.
I see.
So now we have the same table, but with different structure. So the data is the same, but the representation is different. So color is left as row names. Yeah. Cut is left as column names. And these values are just all the mean price values. Okay.
Okay.
So that's sometimes it's useful. And the inverse operation, pivot longer. Okay, let's wide representation. So that's the same that's the same data. We have changed nothing, and we can go back. Sometimes you need to do this operation because, for example, if you download data from, I don't know, Russian central bank site or statistical bureau, then you will see that sometimes year is in columns and months is in row names, and value of your time series is inside the table. So sometimes for data is stored in a bad format. I would prefer one column that's called date and another column that's called value. Yeah. So normally for time series, I'd like to have 2 columns. I'd like to have date and value, and that will be a valid time series. Yeah. Okay, that's a noise. And I may go back from this wide table to a long table. So I can go to pivot to have a long table. I need to take my wide representation, and I need to specify I need to specify, I think, maybe like this color. So let's check. No, that's not a good idea. I need to specify values too. Let's call it cut. at least calls. So calls, I need to select calls from good, I think from good to ideal. Yeah. I know something is strange. Good to ideal. Ah, because I forgot fair. Yeah, I forgot fair. From fair to ideal. Yeah. So what's going on here? I take my wide data. I say that columns fair to ideal, these columns, should go into a new column. Yeah. Ah, no, that's a name. That's mean price. Yeah, mean price. And I need to add a name for, I think, so let's mean price, and name we should change it like to have a to completely recover the original table. Let's look how we rename something inside. Names to, yeah, we need to names to cut. Yeah, and we completely recover our original table with color and cut and mean price as a columns. So we can go from long table to wide table, and from wide table to long table. Okay. Have you got the difference between long table and wide tables?
Yes.
Okay. So, and it's very useful even for time series, because if you have something that is stored year, months, indicator inside. So let's imagine a small table. So let's create, so let's play in a toy example from Central Bank of Russia or statistic from time series. So let's imagine that we have a toy data set that is a table, and we have year is 2029, and let's January equals to, I will introduce only 3 months. January, February, and some more. January, February, March. So a typical, you may often find a data time series stored like that. So you have a year as a column, and you have a separate column for month's name. That happens. That's a horrible data format. And to go back into original, into something that is more like a time series, so we may go to toy. We say pivot launcher, our toy data set. And we say that we take columns from January to March. And we say values will be given a name like, I don't know, GDP. And the names will be given to like months. Yeah. And now I have something reasonable. So I have a date and GDP. Okay. Okay. If you are too shy to even say yes, that's your policy, your strategy. I can't do nothing if you are just too shy to say yes. Just don't be shy. Let's move on. Bum, 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 bum. What we have covered? We have covered some, but I think we have covered what we need. We have covered 3. So let's recall what we have covered. We have covered group by operations. Group by operations. We have covered working with factor variables and creating dummies from factor variables, and we have covered transformation from long table to wide table and back. So sometimes you need you need to move column names into a variable or move a variable into column names. Okay, basically that these 2 operations like grouping and moving from long table to wide table cover all almost all data transformations we need. Sometimes we also need joins. So I think the last so factor variables is a little bit off topic, but it's useful. And the last thing I would like to show when we transform data is join operations. So let's imagine some.
Do you mean inner join, outer join, merge?
Yeah. Join operation like left join, outer join, and so on. So let's create something like I have diamonds, my diamonds data set. So let's say join operations. So the last topic is join operations. So once again, I start with diamonds data set. Let's create a smaller data frame I would like to join to my big data set diamonds. Let's imagine that I just like, so imagine something like boom, 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 boom. Second data frame, right? Second data frame will be something like table. I take unique values from the $cut and cut. So let me look at our second DF data frame. So we have 5 categories, and let's say I have some special information, some other information like mutate, second, and I will introduce one new variable. It will be something like to I don't know, some I like it, I don't like it, so well, I will just organize one new artificial variable, second DF. So I have a cut that is exactly the same as in my original dataset diamonds. And I have a new variable var, and something is so I don't care about this. That's just artificial variable, just to join. Okay, and now I would like to join my second DF to my D. So how we join? Joined result equals to, we do left join. We have left join, inner join,
and so on. I think you have done a little bit of SQL, and maybe you know how to do it in SQL. So I will just quickly show you how to do left join in R. So you specify left data frame. It will be our data frame with diamonds. You specify the right data frame. In our case, it's our second DF. And you specify the variables by which you'd like to make a join. So in my case, I'd like to join by cut. And that's all. And if I look at my resulting data set, I will have an old diamonds data frame with a new variable added, and the join will be done by the cut column. Okay.
Okay.
And you can do other joins like outer join, or so it's called, sometimes it's called full join. I don't remember now. It's a full join. So what do you have? You have inner. You have inner join. You have a full join. You have anti join, anti join. Basically, that's all. Left, inner, full, and anti join. Any questions?
Can I please ask, the difference here is from which side we did it, or is it somewhat else, like left, right?
So what is done? For example, some so you have a good. I think you have a good cheat sheet for. I think it will be in deployer. So I think something like I don't know what do you see on my screen. So I will just stop sharing and start sharing once again. I go to deploy, and I think it's somewhere. Yeah, we can see the difference between left join and so left join, it keeps the left data frame as is. So if you have 53,000 rows in the left data frame, so the resulting data frame will have the same, exactly the same number of rows. So the left data set is skipped. And we take rows from the second data frame and we glue them according to cut variable. And for example, if it happens that you have a cut like super premium in your left data set, but in your second data set there are no super premium cut, then you will have an not available value glued added to your joint data frame. So left join means that the left table is taken as is, and we select rows, corresponding rows from the second data frame. And if something is not found, so an A is glued during the creation of a resulting data frame process. If you have an inner join means the join that selects common values for the variable cut. So for example, in one data set, we have super premium cut diamonds. In other data set, we don't have super premium diamonds. So when we do inner join, super premium diamonds will be absent, because inner join takes only values that are present in both tables. Okay. Full join will combine. So you may see at short, you may look at small pictures there. So in this case, the gray data set is the left one, and we add rows from the second right data set. In inner join, we do not add rows when we cannot find them in the right data set. And for a full join, we take all the combinations. If something is missing in the left data set, it's also included in full join, but with an A value added. Okay. So inner join is like a intersection, full join is like union, and left join, we just keep left data set as is, and we add rows from the second data set if we can.
Understood. Thank you.
Okay,
I have
and
a question.
yeah.
Do we have to remember all the joins by heart for the exam?
No.
So we will have these cheat sheets on the exam.
On the exam, you can do anything. So you can Google. So it's a part of our studio. So once again, I have just so how do you access? No, I don't remember all the R comments. That would be a crazy idea. So you just should know where to find them. So you can Google, you can do anything. On the exam, you can Google. No, it's not a problem. So you can just, what do I need? I need to go to help, cheat sheets, and you have a lot of cheat sheets and some more. And you can Google, obviously, but these cheat sheets are rather good.
Okay, thanks.
So no, it would be a crazy idea to remember all the operations.
Yes, that's what I'm talking about.
No, you don't need to. So it's a good idea to practice a little bit. I will assign home assignment on DataCamp to practice, but no, that will be a bad idea, I think. Okay, so let's make a small break and continue after 10 minutes with a little bit of theory of ETS models for time series. And I think that's all. That will be all for today. So we have a small break and we continue after 10 minutes.
Okay, thank you.
See ya.